So, Rudder, what is it? What makes it different? This talk is a presentation talk to introduce what is Rudder. It starts with what's the tool, and we continue with its current evolution and its long-term view as a product. So who am I? I'm Nicolas Charles, head of customer service at Rudder. I'm a co-founder of the company and of software. I'm a father, and if you didn't hear it, I am French also. So a brief overview of Rudder. Rudder is a configuration management software, as you can guess, multi-platform and multi-operating system. It works on Windows, Linux, AEX, Raspberry, cloud, on-premise, virtual machine, etc. On anything that have an operating system, basically, which is remotely looking like Linux or Windows. In Rudder, we manage something that are called nodes. A node is a system that has a Rudder agent installed on it. So, as you understood, Rudder needs an agent installed on every managed system. The agent will automatically make an inventory of the managed system and send them back to the Rudder server. So the nodes have a dynamic inventory updated regularly. You have information about your system, physical details about the operating system also. For instance, here the installed software on your system. And we can extend this inventory. This inventory can be extended with properties, which are either strings or JSON values, so key values. This information can come from the node itself. You can extend your inventory. It can come from you or from an API when you feed it information on the nodes, or you can pull it automatically from an external data source like a CMDB. These properties can be used to change your configuration or for grouping systems. There are two different types of groups within Rudder. They are used to group your nodes together to match your infrastructure or to match your services, the way you deal with your systems. We have static groups that need to be manually updated and dynamic groups that are automatically updated based on new inventories or change of properties. You can also put properties on your groups so that nodes inherit these properties from the groups. It's a configuration management software. It's not an orchestration tool. We have an agent that checks every 5 minutes by default the configuration of your systems and fix them if necessary, if you are in remediation mode, not in audit mode. So what you will have is you define your desired state with Rudder, so it's declarative. The agent will compare the state of your system with your desired state and correct if necessary. If not, it will fix it, and it will always report back to you based on the state of your system. With orchestration, you will need to manually push something to check the state of your system. So that's the big difference we have between configuration management as we do it and orchestration. We have a web interface in Rudder, and everything can be done through a web interface. This web interface lets you see the state of your system, and it lets you configure your system. You define your policies, you define your routes, you define your groups. Everything goes through the web, can go through the web interface. You can build your techniques. Techniques are a bit like a playbook in the Ansible world, and you can build them through a web interface, like here. It's called the technique editor to build your own techniques. It works either in audit mode or in enforce mode. I will not dwell a lot on this topic. And a bit on the architecture of Rudder. As you can see, there are several parts in Rudder. We have a central point of control, which is called the Rudder server. The Rudder server is where you define your policies. You have the inventories of your nodes. You have the techniques that you've built, and you define on which system apply which policies by applying techniques to groups of nodes. Rudder will generate the policies for each of the systems and make them available for the system. The systems then you manage, which are called the nodes, will connect to the Rudder server, fetch these policies, so they get only their own policies. They don't know what are the configuration of other systems. They get their own policies. They check the state of the system with the policies. If there are any differences, the agent may remediate that, and it sends back the report to the Rudder server. The Rudder server will compare the report it received with the desired state and compute the compliance of the system. This compliance is what we use to measure how correctly configured your system are. I will go more in detail about the compliance later because it means several things. If you have complicated networks or DMZ you need to cross, we have also a relay system, and this relay works like a proxy. So it will fetch the policies for the nodes that are below it or behind it, and it will forward the inventories and the reports of the node to the Rudder server. By default, the agent will check every 5 minutes the state of your system. It's configurable to up to 6 hours. We work with a pool-based strategy. It means that every agent is autonomous, and the agent will every 5 minutes connect to the Rudder server to check if there are new policies. If so, download them and apply them. Report back to the Rudder server. By doing that, it allows for better scalability. We don't need a central point of control when we have to push to 10,000 of nodes. It also means that the systems are autonomous. Even if your network is down, the nodes are still managed, and they will still continue to apply their policy and send all their reports when the network is back up again. So, what's new in Rudder? We are moving toward operational security. Our goal is to enable the Rudder users to prove their compliance and to improve their security posture. That's the big topic for Rudder in the next years. Rudder offers a lot of features already, which can be used for that. We have an agent that runs every 5 minutes, so it can enforce continuously. We have the compliance that is measured. And so we need to make it more useful for security. What we do is we want the system administrator, the security people, the cloud users to excel at their work using Rudder. That's exactly our motto. So continuous hardening, control and audit of the security posture, application of security standard recommendation, patch management application can be fulfilled with Rudder. That's what we want to do, and that's what we will do. How do we do that? So we introduce features around patch management in Rudder. I can share the slide with you if you want. Taking picture. So we introduce security feature around patch management. So we have now the list of updates that are available for each node, and we can make full system updates regularly on the systems. We make it easier to synchronize the configuration between different environments, so between your dev environment, your staging environment, production environment, and between the different production environments if you have several types of production with different level of security or different type of constraint. We now have an API to fetch a specific object and all its dependencies. So the dependencies, I forgot to introduce that. So we can, I'm sorry, I totally forgot to introduce what are the rules and the directive. Rules is the application of one of several directives to one or several groups. So the way you do your configuration is through rules in Rudder, and the rules are applied on system. So now we have an API to synchronize rules between environments, and it will take all the dependent objects. So the rule will, when you fetch a rule, it will fetch the groups and also the directive and the techniques as one big zip, and you can upload it to the next environment. And in 7.3, we also added an option we are also adding an option, it's not released yet, to import the rule without the groups, because on different environments, the groups may not be the same because they don't have the same meaning in different environments. We are introducing YAML in Rudder. Yeah, we are part of the YAML camp. We are making a transpiler from YAML to our agent language. So it will look like that, pure YAML. Something. It will be used for the technique editor. So you will have a one-to-one matching between the technique editor and this YAML, and it will provide a stable format or stable interface for sharing between different systems, different Rudder, even different versions of Rudder. But it also offers other benefits. We are building a component called Rudder C, like Rudder compiler or Rudder transpiler, which take a YAML technique and the generic methods, which are the building block of the techniques. It takes that together. It validates that the YAML is correct, generates the content of the policies for the Rudder server, and it also provides a compile and run command so that you can test locally your technique without the need of having a Rudder server. So it means that it will generate the policy locally on your system, and you can check that the policies do exactly what you want without going through a Rudder server. So you will have a faster feedback loop between what you are developing and effectively what is output by the system. In Rudder 7.3 and 8, we will be working a lot of compliance. So the compliance is a measure on how close your system is to the desired state in the term of Rudder. In 7.3, coming next month, we will have the compliance per directive. So we will have a new tab on the directive page for the directive, the compliance of this directive, either by nodes or by rule. And I don't know if you see, but there is a small export button. We will be able to export it in CSV, because everybody asks for CSV export for every table in Rudder. So that's the first one that's arriving. And what will happen in the World Rudder 8 arc, which will be released in September for 8.0, we will make compliance more useful for everybody in IT. So some specific use case we would like users to be able to achieve is, we have something red on the node. Red means non-compliant. We want to know what is non-compliant and why is it non-compliant on this node. So let's look at other nodes similar to this one. I don't know how we can find similar or how we can define it. We will explore it, and we will see what are the differences between this system. And then we'll see, we will look at the attributes to match this system with the other and see if there is a common point between every system that are non-compliant. Are they in the same data center? Are they do they have the same version of a specific package? Or is there something in common between them, the same property that's not exactly the same than others that are compliant? And we want to be able to export that so that we can show to third-party people or to security, infrastructure team, or etc., why these nodes are not compliant and how they can fix them. So what we will have is, we'll have a language or a way to query the compliance, to fetch information from different data providers, not only from the compliance, but also from the inventory or from an external data source, and merge all this information together to give more meaning to the compliance, to give more meaning to something compliant or non-compliant, and be able to export that in a specific format. So what we will do is we will use GraphQL for that. So GraphQL is a query language based on graph, open sourced a few years ago. It aggregates together different backend, so you can work with completely different backend, and you have also authorization on what you can see. So you can also choose to not expose certain type of information to certain users. This is a big evolution for Rudder to provide meaningful context for everybody using configuration management. And what we will do in 8.0 is this first version, so that we ensure that it works, because we are still not sure how it will behave and how useful it will be. So GraphQL will be our first test, and hopefully a successful one. In 8.0 we will have the core schema for that, and a way to execute query on these schemas. And we will see after how extendable it is and what we can do more with that. Especially we would like to have external provider for data source, for compliance, and first Ansible playbook output as a compliance resource from Rudder, so that Rudder will become the common point of compliance. We have a few minutes for a demo. So when you log in to Rudder, you arrive on a dashboard like that, which shows some basic information about your systems. You have the infrastructure compliance, so the global compliance is a measure of how compliant your systems are. You have aggregated around everything. You have the details there with some error and non-compliance, and you have the percentage of nodes which are totally compliant or not. Here on the left, we have a menu that's not really readable there, but we have a part about node management to see everything about the nodes, and what about configuration management to configure. First, let's go over the nodes. So on this demo, there are 11 nodes. Most of them are 100% compliant. If we get on one, we have more detail about the system. So overview of the system. So it's an Ubuntu, a virtual machine. It has a fairly old agent, 100% compliant. We know when it sent it to inventory last, the number of software updates, and we have a full inventory, as I said. So the networking file system, networking interfaces, software updates. Some systems should be updated, BIOS, etc. I won't go into details. And then we have the compliance reports. So we have a basic hardening on all systems. First, this one is to ensure that we don't have telnet on our system and that the package is not installed and the service is stopped, and it's 100% compliant. This is a technique that has been made through the technique editor. The technique editor is our way to make technique. It's 20 or 25 minutes that we have. Okay. And so these configurations are built through the technique editor, which is a way to build our own techniques. So here it's all the techniques that has been created for on this demo platform, which are I'm not in front of it, so it's harder to see. Yeah, this one. And so we are working with building blocks. So these building blocks are generic methods. The generic methods manage an entity. We have a very large list of things that we can manage. So we can do some audit actions, execute commands, get conditions from something, manage directory, files in many different ways. Really a lot of ways to manage files. Groups, HTTP query, kernel, package management, permissions, and I don't know what's up there. Users, something, schedule tasks, etc., etc. So these are the building blocks for creating your policies, and these policies are simply drag and dropping these building blocks, and you define what you want to do. We don't want the package telnet server to be there, so we have a package absent telnet server, and on Linux we also want the telnet socket to be off. On Windows, it's a component that we want to be disabled, so the telnet server component. These techniques may have parameters, and they are instantiated as directives. Directive is the techniques with all the blanks fill-ins. So we have a forms to fill for this, like quite complex forms. We can define the files we want to manage, their content, some parts we want to change, etc. And we apply them on rules. Rules have a dedicated page where we can have a look on every configuration, every rules, and their status. We have notably one which is non-compliant. It's not this one. And we can see in the detail why it's not compliant. If I can get back to it. Okay. Check user presence on system. No, it's audit Linux. Audit Linux is non-compliant for some reason, and we can check the details. It's because is not the value for Linux enforcing is not present on the system. So we can fix that automatically with Rudder or not. Do you have any questions during the 2 minutes? Yeah.
How do you source information about patches from Microsoft Windows?
We get information from the Windows Update component, which fetch either from internet or from the WSUS based on how it's configured on the system. And same for the patch management on Linux. We are basing ourselves on the output of the apt get list updates and yum, etc. So it's based on what is available on the as seen on the system. So you manage your repository yourself. You need to manage your repository yourself. Oh, it's pretty fast, you know. It's between, it depends on how many point of control you have, but a typical agent run for something like 80 or 100 point of control should be 30 seconds, something like that. It's very uncommon to go longer than 2 minutes, and when it is, it's because we are installing packages, because the package manager are a bit slower. The agent is pretty good. The policies are generated automatically, so there's not much room for tuning the policies once they are generated, and even less because we have regular policy generation based on changes that happens. So we don't have much tuning. What we have more is way to make the reporting more reliable. So we have a lot of variables definitions and things like that that are happening in the background to ensure that everything is reported correctly to the server. But everything that is the technique editor, the generic methods, are hopefully efficient. Yeah.
For the Rudder C compiled for Rudder lane,
compiled to your agent?
We don't have Rudder lang anymore. It will simply compile to a technique, and the technique will be compiled, will be templated for the agent. And we have two different backends, one for Linux and one for Windows, because it's not the same language for both. And maybe in the future we will have other templates for other configuration management software, but we are not there yet, and we don't know yet. Okay, thank you very much, everyone.